Hello, here's another AQA A-level Physics problem from the nuclear physics topic. If you want to answer this question yourself, pause the video now. If you got the answer B, well done. Okay, so the table shows the masses of three particles, proton, neutron and a lithium nucleus. What is the mass difference of the lithium-7 nucleus? So these masses in atomic mass units for the proton and the neutron are the masses of the proton when it's on its own in space, not in any nucleus, and the neutron again when it's away from any nucleus, it's all on its own in space. When we put these protons and neutrons into a nucleus, they have a smaller mass, and that mass is called the mass defect. I'm not sure why it's called the mass difference here. I would call it the mass defect. The difference between the mass of the protons and neutrons on their own and their mass when they're in a nucleus. So the first thing we need to do is we need to find out how much these protons and neutrons would weigh if they were just on their own in space. So there are three protons. We can tell that because that's the atomic number, and each proton has a mass of 1.00728 U. That's an atomic mass unit. And there are four neutrons. We can tell that because that's the mass number, and the mass number is the atomic is the number of protons and neutrons together. So there's four neutrons, and each one has a mass of 1.00867. So if we multiply these numbers and then add the two products together, we will discover that the mass of these three protons and four neutrons has a total mass of 7.05652 U. However, when we put these same protons and neutrons into the nucleus of lithium, that mass is 7.01436 U. So the difference between them will be the mass defect. So if I take this number of the mass of this nucleus away from the mass of the separate protons and neutrons, I discover that the difference is 0.042216 U, or answer B. If that was useful, subscribe, like and hit the notification bell and watch more of these in the series. Thank you for watching.